in this chapter, we are going to go over the basic functions performed by a firewall, the common firewall technologies, the elements of the firewall implementation, and talk about some encryption options you're going to have. So the key concepts are you're going to know by the end of this is what a firewall is and how it works, the types of firewalls, such as individual, SOHO, host software, commercial software, and hardware appliance. We're going to talk about the next generation firewalls and virtual firewalls, the types of filtering offered, and firewall selection. So what is a firewall? Well, basically, the history of firewalls came about. Uh, they are actually evolution of a router. So back in the olden days, we had routers that used to have what was called uh, DACLs and ACLs, discretionary access control lists and access control lists. And with that, you could set up routes by host IP addresses. So you can allow specific hosts or certain networks to access certain things. And eventually they were able to create, somebody decided to add programming and say, well, what if we filter on ports? And that was the start of firewalls. So it's basically a filtering device that enforces a network security policy. So if you happen to have read that Zero Trust, uh, paper by NIST, you would see that a firewall is what they call a uh, network security policy enforcement point. So it basically protects the network against external attacks. So a firewall is meant to sit there on the edge of a network and protect it from what's outside of its designated internal network to defend. Uh, so what it does by doing this, it establishes control of network traffic. And by doing that, it has a set of rules that it utilizes to determine the source, the destination, port numbers, and sometimes even user authentication. And this is the basic fundamentals of any firewall. So what it does, it watches for traffic that fails to comply with the rules defined by the firewall policy and the firewall administrator. So if you don't have a rule that says this traffic can go, you will end up allowing it, it will get dropped or denied. So what it does, it actually prevents these connections from unauthorized sources to protect network systems, services, and resources. So here's my analogy of this. Back in the last chapter, we talked about you had a bouncer at a nightclub with a guest list with specific names and types of individuals out there. They're, specifically prohibited from the club. Another example is if you ever, maybe you guys are too young for this, but sometimes you go in a grocery store and they would have a wall of shame of bad check writers with their pictures and a copy of a bad check they wrote. So a lot of times grocery stores would post these bad check writers. So do not accept a check from this person. So those are some things you had to watch out for those on the naughty list. So we're going to continue on with what is a firewall. So the security policy, which is relied on by a firewall, it's a policy. Well, the policy basically something that are the goals, objectives, and procedures of security for what we want to have in the network. So, generally you could create a policy that says we want to stop any traffic on port 80. We want to only have encrypted web traffic. So by doing that, you can create a policy that says no more HTTP traffic. All traffic must, be HTTPS. That is web-based. So with that, you can go ahead and start with a firewall rule or firewall policy that creates that rule that says, anything on port 80 is denied, or it gets redirected to port 443 for HTTPS to be established. So the firewall can do that and enforce that security policy there. Now, how it works is a firewall compares every packet received to a set of exception rules. So basically, a firewall is going to be set, most firewalls are going to be set to uh, anywhere, from anywhere to anywhere, and deny everything. So that's going to be your default firewall rule. Now, if I want to allow traffic on port 443, I'm going to have to create an exception to that rule by placing a rule above it saying, uh, you know, any traffic from our internal network going outbound on port 443 is allowed. And that is an exception rule. So what happens if I send something out on SSH 22? You're going to see that the packet uh, matches the deny rule and gets dropped. But if I send a packet on port 443, it's going to match that rule, and then the packet will be allowed to go on to its destination. Firewalls follow a philosophy or a stance, again, by the deny by default and allow by exception. And that's exactly what I've just described there. The deny rule is going to be the final and absolute rule. So if you don't have a rule that says something is allowed, then it's going to get denied by default. Firewalls are just basically, big filter, and then everything is an exception to that last denial rule. So what is a firewall? Is it a gateway? Is it a load balancer? Is it a checkpoint? Is it a screening router? Is it a transparent proxy? Does it have segments? Well, yes, it does. It has all of these things can be described as that. So what we have here is a configuration, and it is basically a multi-home firewall and a routing for two segments. So as you see here, just to the right of the internet, you see the multi-home firewall. Underneath it, you have a firewall or an interface on the firewall that allows connectivity to a DMZ router, which hosts multiple things. And to the above it, you see it allows it into a private LAN. Now, some of you may be going, what is multi-homed? So a network interface card or interface on a system is, if you have two network cards on a system, it's called dual homed. If you have three network cards on a system, it is then referred to as multi-homed. If you have four network cards on a system, what do y'all think it's called? That's right, multi-homed. So, yeah, we have a lot of different ways to call anything with more than, really two or more network cards will be deemed as something that is multi-homed. So a multi-home firewall is something that has multiple network interfaces. We have one connection to the internet, one connection to the DMZ, and one connection to the private LAN. So what firewalls cannot do? And keep in mind, we're not talking next generation firewalls here. We're talking about basic firewalls that were the original ones that were designed. So the first ones they cannot do, they don't have any authentication mechanisms. Next generation firewalls do have authentication methodology. They have ways to connect to LDAP or other systems to validate and authenticate the traffic. Can they act as a remote access server? No, they cannot in the original ones. Although next generation firewalls can act as a VPN server and act as a VPN endpoint. Can they act as a malicious code scanner? Original firewalls cannot do that, but next generation firewalls allow for plugins to do uh, code scanning and detect viruses and all that as traffic passes through it. Can they act as an intrusion detection system? Um, Older firewalls cannot do that, but new firewalls and next generation firewalls have the functionality to integrate IDS protection in there. Can they protect against insider attacks and social engineering? Well, this one's kind of a tough one. No, next generation firewalls do not do this still yet, because uh, if traffic doesn't traverse the firewall interfaces and go from one interface through it, and traffic does not pass through the firewall, it's not going to detect an insider attack on other systems unless it actually tries to go through the firewall interfaces. And it's hard to social engineer a firewall by telling it, hey, uh, I'm a beautiful person that would like to take you away to a tropical island and give you millions of dollars. They just really don't fall for that. So social engineering just doesn't work when you're trying to social engineer a firewall. Can they protect against threats from removable media? No, again, it's something that this would be more for an endpoint management device and hosts that protect it. So that would be something a firewall does not do. Can they prevent a physical attack? Um, Operating as a firewall, no, they cannot. But I'm sure, if you picked one up and you flung it at an intruder or hit an intruder with it, it might actually help prevent a physical attack. But I wouldn't count on it, no. Um, can you protect against misconfiguration of other network equipment or poor security management? Well, not until we integrate AI into them and they take over, and then they'll determine that we're probably more of a problem than they're worth, and so they'll eliminate us as security managers for themselves to deal with. So those are some things we have to look at in dealing with for firewalls and what they can and cannot do. All right, here is what they call a border firewall. Now, border firewalls sit on the perimeter of the network, and they do not filter any type of internal communications. So this firewall right here in the middle between the internet and that router on the left-hand side, all that does is filter traffic that traverses the internet and the internal network. So that is what a border firewall can do. But traffic from the systems on the bottom to the systems on top, since they don't traverse it, the firewall is not really in there to protect any of it. Okay, so people ask, why do you need a firewall? Well, as you can look around, you're online, everyone else is online almost all the time. So most systems, need to have some way of getting a public IP address or get out to the internet. Um, and if you actually put something on the internet, uh, the chances are it'll get detected, scanned, and probed within minutes of obtaining a public IP address are pretty quick. I mean, if you ever go look at your external logs of your external router, you can see pretty much all the different things that are hidden on it if you enable all that logging for it. We have malicious programs that are constantly scanning things on the internet. Like I said, the internet's a dangerous place. Being directly on it is usually you're going to get hit with something pretty quick. So a firewall is basically a tool to prevent the misuse of your LAN. So it is a guard between that. So it guards those network segments of your private network. And there's also a thing called host firewalls that come with a lot of anti-malware systems that help lock down your host and protect it on the network itself from internal other insider threats and all that. Um, Here's a good point. I don't think I brought this up yet. So, how many of you have ever worked in construction or been around any kind of naval ship, or those of you in the Navy, uh, or any of those type of things like that? Basically, if you ever go into stairs and you see that area is just surrounded by cinder blocks, and you just have a door that's made out of metal. If you ever look at those doors, for all the stairs, they're usually made out of metal of some sort. They're usually pretty heavy also, and there's usually not a lot of gap when they're closed. Well, the wall around that stairwell that goes up and down the building, those are firewalls. And a lot of times buildings will put other firewalls in between sections of itself. If you're ever on a naval vessel, such as a cruise ship or actually a military ship, as you're traversing between sections of a ship, you'll see a solid wall there of the ship. It's a compartmentalized wall, and there is an airtight door that goes between them. If that door is open, stuff can pass. If it's closed, it's pretty much locked, and you need something to open it up. If you go between buildings, you have to go through a set of doors between different segments of a building. These are areas which are entrances in a firewall. I like to use that as an analogy to our software firewalls that we use, or well, every firewall is technically software, whether it runs on an appliance or runs on a host, or if it's deployed in the cloud. Um, these, when you have a port open, it's like having a door open, and if you have access restrictions on it, it's like having like a card key that allows certain things in and out of those doors once you open them. So that's my analogy of how you can equate a firewall to something in the real world there for you. So here's an example of a private network using firewalls to separate subnets securely. So as we see here, we have a firewall here on the left-hand side connected to a router, and this router is connected to two other firewalls. Now these are LAN segments internally. You have a router that can route between all three of these firewalls and to other areas of the network. A lot of times we have what's called firewalls in our internal network to protect internal LAN segments, such as uh, our let's say our finance area or our HR information. These are usually firewalled off from the rest of the network, and you have to have special access to get through those areas. So you can segment up your internal network with firewalls really well to do that. All right, how do firewalls work and what do firewalls do? So there's three different types of firewall implementations. The first is called the bump in the wire firewall, and this is a separate hardware firewall implementation that physically segments two LAN segments. Another implementation is the bump in the stack firewall, and this is a firewall that is implemented in software. You see that like if you install some anti-malware software on your system, it'll be on your laptop or your desktop, or if it's on a server. These are mainly host software out there. And then there's also the Bastion host firewall or sacrificial host. This is a firewall that is similar to the border firewall we saw earlier. It stands along the path of a potential attack and takes the brunt of attack. So if you're in a small office, home office environment, you can put a Soho router out there that's directly connected to the internet, and anyone who is on the internet trying to attack you would just take out everything on there, on that firewall itself, and you would be able to work behind that firewall, hopefully without having anybody get in. So the idea of the firewall is to prevent malicious interactions from the host software or to the host software from somebody trying to do something very bad. One terminology you're going to hear is called the dead man switch. The dead man switch is used if the firewall fails or goes offline. So it also takes out the connection. So let's say you have a power failure or somebody throws something on you and your software goes boom, it crashes. Uh, the firewall will trigger the interface to be deactivated. So you're essentially taken offline after that. So here we take a look at the bump in the wire implementation. So here we have a firewall sitting between two segments, and these two systems are prevented from talking to each other unless it is allowed by the security policy. All right, here we have the bump in the stack firewall. So here on this, you would see the firewall installed on each of these two systems in the middle of the two routers here. And finally, we see an example of a bastion host firewall. So as you saw the border firewall picture earlier, a bastion host is somebody who would take a direct hit from anybody trying to intrude into it from the internet, protecting all of the assets behind it. So how firewalls work and what do firewalls do? So they basically screen and filter traffic. We've already talked about that. Uh, Now this is the next one. I highlight it because it's very important. They deny by default and allow by exception. You'll probably see this on some quizzes coming up. And they'll be worded many different ways, so be careful. Traffic filtering. It is based on the information in the packets or in segment headers. Uh, what does that actually mean in real world terms? Well, this means it's basically this. If you're looking at information in the packets or segment headers, you're looking at the protocol type, the source and destination address. That's where the traffic filtering is most likely based on that. They filter and block protocols and certain types of protocols out there. So that is what they're doing. So you can say, I'll allow HTTPS, but I'm blocking HTTP. I allow SFTP, but I don't allow FTP. Those kind of things we have out there. You can differentiate between networks and subnets. So basically, a network is a set of LANs based on a subnet, but a subnet is a subset of a network. Just think of it like that. It's just how you subnet it and cut up a network as a subnet. Firewalls serve as the boundary between network areas and boundary devices. So what I mean by boundary devices, this could be like internet firewall. This is your connection to the internet and your internal network. A firewall should go right between there. Firewalls can act as a general filter for malicious activity, or they can act as a one-way sieve. So you can set your firewall to just allow traffic outbound and allow nothing inbound from it. And that is a good way to do it, and that way you can concentrate on all things that way. And then you can have another firewall that only allows traffic inbound to certain things in your DMZ. That could be something else you can do, and you have separate firewalls for that. They also support inbound authorized connections with the LAN, such as VPNs. So you can have a VPN behind a firewall that allows it to say, hey, these are the areas where I allow VPNs to come in from. And you can have next generation firewalls. You can set up geosynchronous information from that. So if somebody has an IP address from Russia, you know, you probably don't want to allow them in, or from China, unless you have people that are working from Russia or China in your company. So in earlier classes, you may have learned how NAT works, or you may not have. But a firewall will do port forwarding across the system, or also NAT forwarding. So an example of port forwarding is if something is published on the internet on port 8081, the NAT firewall can then transcribe the traffic destined for port 8081 to an internal server on port 80. So it takes the internet address coming in of the incoming traffic from the source of 208.40.235.38, uh, and it hits the firewall. I'm sorry, that's the destination. The NAT firewall hits that interface and replaces it with its source IP address of 192.168.5.1 and sends it to 192.168.5.74 on port 80. Again, traffic destined for that internal server on port 80 on the internet is published as 208.40.235.38.81, and then that firewall down there translates it to the internal address. So, how firewalls work and what do they do continued? So, firewalls can translate ports and forward from one destination port to a different destination port. They can manage and control traffic by regulating what is coming in and out of that system. They can also block or filter any outbound traffic, that should not be returned. Or if you have something like a remote access Trojan that's going off, it should be able to detect and block that because it would not match the rule. It can perform basic proxy functions. So anything destined, it can do kind of a natting and even some rudimentary content filtering. It can perform address conversion through the use of address conversion or a translation system, i.e. NAT. And it can also log events, which is very important for troubleshooting networking issues. All right, so we have different types of firewalls out there. The first one are your personal firewalls, and these are usually, uh, bought along with some anti-malware devices, where you can buy a small software like that comes on the Windows operating system called Windows Defender or Windows Firewall that comes built in. These are some personal firewall software that is very limited in scope, but can do some generic protections of a system. Then again, we have some commercial software firewalls, and these are software firewalls that can be used either on personal devices or in other systems that you can set up. That you can buy a software package and set up your own server for it and convert that into a firewall. Then you could also buy a personal hardware firewall, and these are little devices that you can go and buy at Best Buy or Amazon.com or other places. And they purchase them, and you can put them in your home environment to protect your systems from external intrusion. And then, of course, we come to what we're all here about, the commercial hardware firewalls. These are some of the more expensive and uh, more dynamic models out there that most enterprise uh, corporations use. So you'll see a lot of them out there. These are like your checkpoints, your Palo Altos, your Cisco firewalls, your Fortinet firewalls, your Sonic walls even. So what do individual and small office, home office firewalls, what options do they have? Well, they have protect you against passive threats, and those you seek out to be harmed. That's kind of what it means. Like, hey, if there's something going on and you're not aware of it, it'll get you. You know, uh, it'll stop and protect you from like infected content or anything like that, like from downloading a malicious link or anything. It helps against those things like pop-ups, blockers, cookie filters, and other things like that. For active threats, you have to kind of get into and subscribe to their subscription service where they download signature files for you. They also provide hacker, intruder, and automated worm detection. Although, hey, somebody's coming in trying to spoof you, they'll send you an alert. It'll block it usually and kind of helps gather that information about that. So it helps protect against these threats, and you can get some reasonable security protection from these. It's inexpensive and it blocks most people who are just trying to poke around. It protects you from the script kiddies mainly. And so if you ever want to look at a privacy blocker, you can go into Firefox and select options, and this is kind of what it looks like, where you can block certain things, cookie settings, block pop-ups, and other things like that. So blocks a lot of trackers and stuff like that. So here's a dynamic picture of what that looks like. And next we move into like the individual other firewall options. So you can find these like in Windows Defender firewall that comes out there. I mentioned that earlier. In Linux, you have IP chains, IP tables, PF nut filter, and Viata. And these are all different little free or low cost implementations of firewalls that come with the operating system, or it can be, apt-get install some of these things too. Um, there are some things which are, hosted by internet service provider connected devices or routers or exploits. These are, basic tools. Um, if you ever look in your cable router or your fiber router or whatever you have at home, uh, if it's AT&T or Verizon or T-Mobile or Spectrum, you go inside these little things that connect you to the internet. They have a rudimentary firewall in there. It does IP address blocking, port blocking. You can do protocol. You can do a blacklist technique out there or blocklist technique, if you will. Next, we come to managing the firewall on an ISP connected device. Most of them, you can just kind of open up your web browser and enter the IP address of your gateway, and you can see a lot of stuff. If you want to know what it is, you can do an IP config on a Windows system or an IF config on a Unix-based system to see what your gateway is, and you can use that to determine, put that in your web browser and see your connection come up. And for your ISP, usually on the side of the box is a sticker which has the password of it. Or if not, you can call the ISP and ask them for access. And if the ISP is telling you not to go and look in their stuff, just switch an ISP. There's probably a better offer for you for switching. You can also add your own firewall between the ISP connection and the network device. So after your thing, in my home, I personally have another firewall that is between the ISP and my internal home WAN that I've, prompted and, protected. So if you want to talk about converting a home router into a firewall, there's ways to do it. Here's some instructions. You enter the IP address, start run, put the command ipconfig, and you can go ahead and change the SSID, block unnecessary ports, and then you can go to grc.com and use the shields up scanning. And if you do that, well, here's an ASUS router that you can convert, and it looks like you have your wireless stuff here for a wireless router. A lot of different configurations all throughout the system. You have your firewall down the lower left-hand corner, which can provide a lot of stuff in there. And then if you want to go to Shields Up, you can go ahead and go to Shields Up and that grc.com, and you can validate, and it can do just a remote port scan on your system, tell you how well you're actually protected. Here's a list of protocols that you're going to run into and you're going to see a lot on, and what they're for. If you don't know what they're for, you can read through this list. I'll let it sit here for a second. You also should have a copy in the notes you downloaded. And here's another continuation of the list. A lot of these are stuff you should not allow to go through. And we'll move on to the final stage of lists. So you can see a lot of different ports here. 443, unless you're running a web server behind your firewall, you probably want to do it. And you want to block all these ports mainly. All right. All right, so uses for host software firewalls. Well, host firewalls kind of only protect your local computer because they're installed only on your local computer. They filter traffic only hitting that system only. They can filter other systems, but only if you're using something really archaic like Windows Internet Connection Sharing. And you don't really see that much anymore in modern times. So you're really not going to have to know about that much. So there's also host-based firewall or personal software firewalls, and they're not optimized. One of the famous ones that used to be real popular was a system called Black Ice, and it was a home firewall system. Everyone used to go and download it or buy it and use it. And then everybody complained when their stuff stopped working. So in Windows 10, there's a host software firewall. It's called the Windows Defender Firewall. It's very sufficient. It is a little bit more advanced than a lot of other systems, so give Microsoft some credit for that. You can use it in your home, small office, mobile, on your laptop. You should always have something like that enabled if you are, taking your laptop, connecting it to more public Wi-Fi's, like say at an airport or at Starbucks or at La Madeleine or whatever restaurant you may want to go into that offers free Wi-Fi. So these are some things you want to make sure you always have enabled on your personal systems. So one thing you want to do is also, if you don't have a domain at home, you create a work group that allows for, same password protection when you're doing file and printer sharing between systems. So make sure you password protect your stuff. You can also set granular control and configuration in the management interface. And there also is extensive logging that can be done, and you can view that in your event logs. And here's a little look at what it looks like. Here's the Windows Defender profile, and you can see on the left you can create inbound roles, outbound roles, connection sharing roles, and monitoring. And you can get down to how much monitoring you want to get into on this system. All right, Linux firewall. So you want to run Linux, okay? There's different ones out there. IP Fire, IP Tables or NetFilter, Untangle NG, UFW, BIOS, Smoothwall, and in our labs we're going to be using pfSense. So I have provided a manual for pfSense that didn't come with the labs, but make sure you download a copy of the manual, because it's always, if you come to me with an issue, I'm going to say, did you RTFM? And that always means read the fun manual, because manuals are fun to read, aren't they? But you really do learn a lot. And I will say this, those who actually read the manuals, are soon known as the subject matter experts, and they usually are very well relied upon in any kind of place of work because you'd be surprised at how many people do not actually read those manuals. So, commercial network software, all right. So, or commercial firewalls rather. You install the stuff on you install this on a hardware and provide network security sources. Um, you can install it on Windows if you want. Many of them install on top of Linux. Many of them become hardware appliances. But some examples are Checkpoint, uh, Palo Alto, which is not on there, uh, Cisco Next Generation Firewall, uh, and the ASA Virtual Appliance. You have the FortiGate or Fortinet FortiGate virtual machine out there. I scratched out Huawei because um, they've deemed to be unreliable. I wouldn't touch any Huawei. The only thing I'd ever use a Huawei for was to maybe help create um, you know reefs off the coast of in the ocean. Fake reefs. SonicWall, once owned by Dell, is a nice medium business-sized software. Really good piece of equipment there if you need to have something for a medium-sized business. While Checkpoint, Cisco, Fortinet, Palo Alto offer enterprise level stuff. So, use for hardware and appliance firewall, they're basically dedicated devices specifically built and hardened to support these firewall software that runs on them. You don't need to require additional hardware or software for deployment. Not always true because a lot of them require a server to be out there for you to install the management software for uh, enterprise management if you have that. But if you don't have that, you can actually uh, connect to the firewall itself too. So you need network connections and power connections, of course. You can't run a firewall without power. You have to have a dedicated hardware resources, not shared with others. So you want to go ahead and install it on its own stuff. And you don't want to think you can put it on a router or use it for other things. A firewall should only be used as a firewall. And you can use it to protect a single network or a single system, however you want to do it. Depends on what your budget is and how far you want to go. So that brings us to the topic of next generation firewalls. So remember earlier we were talking about all the things firewalls can't do, and I said, with caveat, we have next generation firewalls which are doing a lot of these things. So we see they offer capabilities beyond the traditional firewall functionality. A lot of them provide IDS, IPS. They are more cost effective. They offer clustering, so you don't have a single point of failure if a device fails. Um, they're called third generation, fourth generation, fifth generation firewall technology nowadays. They can be actually very complicated to configure due to all the different services. And deployment and management and log management becomes more complex. They offer like application scanning. They offer things like geolocation or geosourcing, restrictability. They offer anti-malware integration. So there's some great things. IAM integration. So these are really cool things that they offer in next generation firewalls. Uh, so what are virtual firewalls? What is it? Is it something out there in the ether? Well, those of you who are working in virtualized environments or cloud environments, which is just a really big virtualized environment, firewalls running between virtualized clients and server operating systems. So if you're running a cloud environment, um, you build out your enterprise out there. Before you connect to the internet, I would put a virtual firewall in there to help block out a lot of things. You don't want to leave stuff exposed on the internet, especially if you're running a infrastructure as a solution to IaaS system, where you're responsible for all the things in the cloud environment. So infrastructure as a service is great because then you can configure your own virtual firewall in there and configure it for your exact needs. So when you're using virtualized firewall products, you need to make sure that their filtering is also the same as the standard they use for physical protection. So if you're using a virtual and a hardware, a lot of them is not going to look very different at all in the way they should manage. If you do see a lot of discrepancies between the hardware version and the virtualized version, I would bring that up to the vendor and find out why there's those discrepancies. Some of the benefits of creating virtual firewalls, you can deploy them really quickly. If you have to buy a hardware firewall, you have to wait for it to be shipped. You have to wait for rack and stack. You have to wait for the power to be adjusted. If you're doing virtual firewalls, you can deploy them really quick. Just click, push, pay for the license, install your license on it, and then you're good to go. You can use them for isolation, traffic management, quick recoveries. You can use them for test environments, separating stuff. Virtual firewalls are great for a lot of different things like that. Um, hey, earlier we talked about dual home and triple home firewalls. Well, multi-home firewalls, as I said earlier, dual home has two interfaces, triple home has three interfaces, multi-home more than one interface because it's multiple. Uh, when you're doing multi-home, the benefits are that you can have multiple networks connected in and have the firewall actually apply filters between networks. And you can create zones off of these networks and a number of other things that you can get to do a lot of granular controls and a lot of rules out there. Um, you can also use these as a routing junction point as a gateway to prevent unfiltered traffic from going from one segment to another. You can really use that in no way the firewall could be bypassed. So you have more granular control on that. So that's really important when you're dealing between different zones of trust. You use this as a policy enforcement point. What's the difference between ingress and egress filtering? First, ingress means inbound, for those of you who didn't know, and egress means it's outbound. So just for that knowledge there. Uh, Now, they both of them can perform blocklist or blacklist, as the older terminology is, and whitelist or allow list filtering. Uh, as you can see, a lot of vendors are moving away from blacklist and uh, whitelist because management and those coming from other areas were really getting confused by that terminology. And so they're changing it to a lot to blacklist, allow list. Um, Ingress and egress filters can do protocol and port blocking, and they can confirm authentication and authorization before communications can continue. Now, ingress filtering, they check for filter spoofed from the source addresses that come from the opposite side of the firewall. So if I send a firewall something from the external and I'm saying, hey, I'm coming from something on the same subnet, it's going to find that to be a spoofed address and drop to you. Filters that are spoofed, that have spoofed addresses, when you're leaving the network, you know, if I have outbound traffic and I'm already providing an external public address on there, that's going to be something to watch out for on the egress. So there's different types of filtering a firewall can do. Uh, One is a static packet filtering. Another one is application proxy out there. You can see stateful inspection and dynamic packet filtering. And this is a really important thing to touch on. Stateful packet inspection is the where you go actually in there and look at the data of the packet and the stateful inspection of that to make sure that it's not a different session or different thing in there. So we can get out there and get a little bit more deep in there. Uh, you can also create a circuit proxy to make sure everything is going through the same pathway. You can do network address translation and also content filtering to look inside certain like web traffic to make sure you're going to a website, let's say if you go to a website for gambling and you have the category of gambling blocked, uh, it would block that. Or if you're going to, like, say, one of the entertainment providers or social media and you have those blocked, the content filtering will kick in and determine that those destinations should not be allowed. Okay. So there comes a time when you need to select which is the right firewall for your needs. And there are some things you need to consider. The first one is your security assurance, and that means how good is the security on this thing. The next one is privilege control. Privilege control means how granular can I allow, uh, permissions, in and out. Can I what kind of controls do I have to allow who can go where and when and what time and how they do it. The next one is authentication, and that is validating it against a set of known users. So authentication, if we remember from the CI triad, means um, who are you or who I am, and you can validate that user or service. Have a validation for that. Audit capabilities. Are you in an industry where you need to have very granular controls and show that you have certain, you're logging everything coming in and out, all the connections for that. So you have to have that audit capability. You also need audit who made changes to it, who opened it up to review things. These are all things that can be audited. How flexible are the firewall? Can I add different nodes to it on the fly and have the policy push to it and have it automatically join a cluster of load balancing to add capacity? These are some kinds of things about flexibility for it. Other ones are performance. Hey, this is one thing all software salesmen or all firewall salesmen are going to tell you. Oh, our firewall performs faster than anything else compared to the current vendor you're using. Well, I can explain a story. I was working for vendor A, and we were working on anything, and then our competition was saying, "Hey, look how fast our firewall is compared to theirs," and they did these benchmark tests. What they didn't tell them is they configured on our firewall for their benchmark test. They configured everything that needed to be done. Everything. They configured it all the way to the max. So every check was being done, everything like that. For their firewall, they made up two quick rules and disabled everything else and showed it was like 3 times as fast. Uh, Ironically, when we configured them apples to apples instead of apples to oranges, our firewall still had a better performance than their firewall. And we could also have more capacity than their firewall before it went down. We tested under heavy load. So these are some things you're going to have to worry about and test for yourself. Scalability is also something that's kind of related to that flexibility there, where, how much can I add it in? How fast can a vendor get me other firewalls if I need them? And stuff like that. Um, so a lot of times come to wonder, and this is kind of becoming a mute point these days, the difference between buying a firewall or building your own. Well, off-the-shelf firewalls, they offer the easy setup, they often work out of the box and only need to be plugged in. Custom-built firewalls, they can be more expensive, you have development costs and all that, and require a lot of IT personnel and effort to do. So that leads us to our summary, where we talk about what a firewall is and how it works, the types of firewalls, individual firewalls, the SOHO, small office, home office, host software, commercial software, hardware and appliance. We discussed next generation firewalls and virtual firewalls. We talked about types of filtering and also firewall